Hi everyone, this video is for section 5.4, the other trigonometric functions. In this problem, we're told that tangent of theta is equal to 4, and that theta is between pi and 3 pi over 2. With just these two pieces of information, we're going to be able to solve for the remaining 5 trigonometric functions. So, first off, let's start off with what we know about tangent of theta. We know that tangent of theta is equivalent to a ratio. So I'm going to change 4 and write it to look like a ratio or a fraction. From here, my definition of tangent tells me that it's a ratio of y over x. So straight away, we can tell you that y has a value of 4 and x has a value of 1. But we do need to be careful because we are given some information about the quadrant that it's in. So the quadrant that it's in, let's just go ahead and do a quick sketch of a circle. We're told that the quadrant that it's in is going to be between pi and 3 pi halves, which is the third quadrant. From here, ask yourself what you know. If we refer back to our unit circle, we've used our unit circle in order to find our cosine and our sine values for angles that are usually, 0, 30, 45, 60, 90, and so on degrees. Well, we also have a definition of what cosine and sine is by looking at ratios again. Cosine is going to be x over r, and sine is going to be y over r. So let's take a look at the image here. The x values that create that border for your quadrant 3 are going to be negative values. So this tells me that my x value in my ratio for the third quadrant has to be negative. I also see that I'm using negative y values in order to create that other border that forms the third quadrant. So this y has to be negative. Okay. So another thing to note here is the radius. So the radius is a measurement between the center of the circle and the outer edge of the circle. It's giving you a distance. And if you recall, distance can never be negative. I mean, it wouldn't make sense to have a radius of like -2, for example. So this tells me that the radius that I'm using in this problem, this has to be positive. Okay, so before we determine what the radius should be for this particular circle, we need to make an adjustment to the y and x value that I have outlined in purple on the left side of the screen. We had said since it is in the third quadrant, the x value is negative and the y value is negative. You can go ahead and confirm this by, again, using what we know about the ratio. Do you agree that a -4 over a -1 simplifies down to a +4, which was the initial information that we were provided? Now, we're going to go ahead and find r. Well, simply by using the equation for a circle, we can uncover what the radius measure is. We have x, and we have y. And by plugging them in, notice that the only variable that we have left to solve for is our radius. So -1 squared is +1, -4 squared is 16. If we combine like terms on the left-hand side, we have 17 is equal to r squared. In order to get rid of that square on my variable r, I'm going to take the square root of both sides. And this simplifies down to a root 17 is equal to r. Note that we don't really have to struggle over what sign we should choose here. Since we're dealing with radius, radius must be positive. So I'm going to use a positive root 17. So we've done most of the grunt work. We actually have all the tools that we need in order to solve the remaining 5 trig functions. So sine of theta has a ratio of y over r. Y is going to be -4, r is root 17. But this is bad math grammar if you leave your answer like this. So we're going to have to rationalize the denominator, which means that we're going to multiply the numerator and the denominator by a root 17 in order to clear that out. This will simplify down to negative 4 times root 17 all over 17. Let's move on to cosine of theta. This has a ratio of x over r, which is equivalent to negative 1 over root 17. Lo and behold, we need to do another rationalizing of the denominator. So I'm going to multiply both the numerator and the denominator by a root 17. This becomes negative root 17 over 17. Because we're having so much fun, why stop there? So now let's go ahead and do cosecant of theta. Recall that cosecant is the reciprocal of sine. So that means that I can just take my ratio for sine and do its reciprocal. So now I'm going to have r over y, which is going to become root 17 for r and negative 4 for y. Now, you can leave the negative down here, but what I would suggest in terms of presentation would be to either move it up, or if you want to go completely middle of the road here, put your negative right next to your division bar. Okay? So here is our cosecant. Let's go ahead and do secant next. So secant of theta, if you recall, is just the reciprocal of cosine. So that means that I just need to take the reciprocal of x over r, which is r over x. So r is root 17 all over negative 1, which will just simplify down to a negative root 17. Okay, the fun is almost done. So now let's go ahead and take a look at cotangent of theta. Recall that cotangent is the reciprocal of tangent. So instead of y over x, we are going to look at the ratio of x over y. Well, x over y is going to be negative 1 over negative 4, which simplifies down to a positive 1/4. So again, just by being given a trigonometric function result and a quadrant location, we have been able to uncover the remaining 5 trig functions. Okay, so I hope this video was helpful. If you have any other questions, please come see me or send me a message.